So again, thank you for your time. I'm going to talk about the power of DeFi Legos in Agoric connected to the real world. You may have seen I mentioned earlier about accelerating DeFi, and these two questions about these two quotes from Mark Miller, our chief scientist at Agoric, and Sergey at smartcontract.com and co-founder of Chainlink. Those put together what we're all trying to accomplish. I'm going to be focusing on how we do DeFi Legos, how they get composed, which ones are available, and how it is that we take the information sources of Chainlink and pull them in to make them available as a DeFi Lego. One of the key reasons to use Chainlink and the oracles in Chainlink, even if you could do it yourself, is time to market, right? It's all about being able to rapidly put together things where if there's someone who's really solving a part of the problem, whether it's in a software component that implemented an atomic swap so you don't have to, or in an oracle component that implemented access to the gold price so you don't have to, it's hugely valuable to be able to leverage those, because since that's their focus, they can put a lot more attention into maintaining correctness, ensuring it's secure, ensuring the data is high quality or the transaction is high quality, ensuring audits happen, all those kinds of things. And so that's why historically in software engineering, composition where you can really use an existing component has been one of the primary enablers of exponential growth in communities, exponential growth in application capability, exponential growth in expressiveness and power of the toolkit you're using. So Agoric's building a chain that and a crypto economy that enables rapid composition like that, and that's what I'm going to go into here. Okay. So first, let me have a little bit of introduction about the Agoric stack. I know a question came up about what are we built on. Agoric is a platform where most of it is agnostic to the underlying consensus engine, but we require fast finality and reasonable performance. So we use the best-in-class, battle-tested consensus engine of Cosmos, which is Tendermint. We also work very closely with Cosmos and the extended Cosmos community on both DeFi and integration and interop, and on the inter-blockchain communication protocol, so that Agoric, when it launches, will not be launching in a vacuum. It will not be launching another island. It will be launching a connected chain that connects to assets in Cosmos, connects through Peggy to assets in Ethereum, and to the markets there. On top of this, we build our secure runtime that provides the secure version of JavaScript with confined execution. I'm not going to spend any time on that, but we have lots of detail, lots of engineering. We've been part of this JavaScript standards committee for many years, long before even Agoric was founded. And in order to be able to provide and enable the secure composition that we rely on for smart contracts. And then once you get there, now we're starting to get into the enabling framework for smart contracts. Like I said, 15 years ago, people struggled to do a little bit of very cool animation and interactivity with JavaScript, and experts could do some pretty impressive things, but now beginners can do much better than they could, simply because they get to build using components that other developers built. And they get to build components and share them with their friends, or publish them and get credit and then have people build and use them. And so we're doing the same thing for smart contract components. The electronic rights transfer protocol is not a crypto protocol. It is an object protocol for how you can use objects to be able to represent digital assets, transfer them, claim them, store them in accounts and purses and so forth. And I'll go into a little bit of detail about that, because these are where the first Legos appear. On top of that, we then build our smart contract framework. And I'll say a little bit about that, but most of my focus is going to be on the two layers around it, which are the fundamental Legos out of which everything else is built, and then the user-defined contract that include everything from atomic swap to Uniswap variants to covered call and so forth. So we're going to see, and obviously Oracle information as well. And in this stack, DeFi is all throughout. Like I said, DeFi appears in ERTP, but DeFi appears in our underlying integration with the staking and rewards infrastructure that we'll be talking about next month. Our focus here, though, is in giving you some of those DeFi components that we've already built, so you can then build on top of them, use them to build larger, more interesting dapps. Okay. So ERTP, Electronic Rights Transfer Protocol, and what I call the issuer kit. We use the term kit when you can get a bunch of objects that are all connected to each other. So there are some key objects here that are the glue that bring together that are, as I mentioned in the chat earlier, they're the glue that enable us to have a single JavaScript smart contract that works for assets, whether it's the native currency or the native staking token, whether it is a wrapped Bitcoin brought onto ETH, pegged over Peggy, brought onto a Cosmos zone and brought over IBC onto our chain. And Atomic Swap doesn't care. It can work for either of those. The AMM, no problem. Fungible token from ETH, some atoms from the Cosmos hub, local liquidity token, all good, right? So and it's because we get to actually use, that thing called object-oriented programming that was such a revolution in the 80s that, now we get to use it for smart contracting. Okay, so the first is, some of these are very simple, but the important thing is having the right simple abstractions. These are ones that we have evolved over many rounds, starting from doing smart contracting in the early 90s pre-blockchain. So purse is a container of a particular kind of asset. So think of it like a coin purse. It contains either fungible or non-fungible of a particular kind of asset. A payment is something you withdraw from a person, can transfer to someone else. And it's just another JavaScript object. So I can say, John.enjoy open paren payment close paren, right? And so my ability to program with it, hand them around, think of it as I pull out a bunch of coins, I hand it off to you. A mint is the thing that can create new tokens of a particular token, new non-fungible tokens, new fungible amounts, what have you. Once the mint is destroyed or unavailable, now that currency is minted all it's ever going to mint. There's no way to get any more. But if you've got a, store an NFT app or, that's creating magic items for a game, you can have a mint for that. Creating non-fungible tokens is as easy as creating fungible tokens. And then an issuer is the, where a mint is closely held, because that's the authority, that's the ability to actually be able to create this stuff. An issuer is widely held, so anyone can verify that the thing you just gave to me, and this is the magic that makes this object-oriented program, this protocol work in JavaScript so nicely, is that the thing you gave to me, which could be a window, could be a handle on a timer, or it could be the payment that I asked for, you use the issuer to both verify that it is indeed a payment in the currency that I was requiring, and I now have exclusive access to it. And so it arranges both of those together, that I get exclusive access if and only if it is exactly the asset that I needed. Okay. And then finally, I keep mentioning a kind of pay, a kind of token, a kind of NFT. Well, there's a few things to glue all this together. The brand is the thing that says, yep, this is wrapped ETH that came over Peggy, or this is the underlying stable coin, or this is, Joe's magic items from Joe's Magic Item Emporium, whatever it is. Right? This is a receipt. And indeed we use it in oracles to have a brand of, these are quotes issued by a particular Chainlink oracle, which is the one you and I agreed on for doing business, right? And then finally, there are amounts, which are the ability to talk about an amount of things. One of the important lessons from CeFi is, never pass around a raw number, right? When brokerages first went online in the early days of the internet, Schwab and E-Trade and a few others that are lost to the mist of time. Pretty much every single one of them had a bug where they provided number of shares in the amount column and amount in the number of shares column, which, as you can imagine, or a delta in an amount column, or one of these things where the numbers didn't have units, and so by gosh, someone swapped these things. Amounts are, it's not that I'm going to pass you 30, it's that I'm going to pass you 30 atoms, or I'm going to pass you 30 concert tickets for July 4th, right? Or whatever it is, it's that I'm passing you a real, I can describe a real set of assets, right? I can describe 20, no. I can describe $20. You want to be sent $20, not just 20, right? Now, an amount is not the actual payment, right? You can only transfer assets with a payment. Amount is just the description, just like I'm talking about $20 here without having to pay you all. Okay. So those ERTP Legos, those are the initial Legos, right? Purses, payments, fungible tokens, easy to use non-fungible tokens. Those are key things that lots and lots of contracts use. And there will be a workshop where Kate walks through those in detail, where we built additional fungible assets, additional DeFi Legos on top of it, a simple faucet, or a simple NFT store, or NFT sales contract. And Kate will be walking through those, through a couple of those tomorrow, in order to introduce the basic concepts. And not only do those have, not only do those have reusable smart contracts you can plug in and have a faucet for your own token, or do NFT sales for an NFT you mint for the application that you built, but they have dapps as well to be able to show these things. And so, they come out with simple dapps to be able to demonstrate this, and to demonstrate the end-to-end of going from a contract on chain to a cloud service that might be aggregating information for you out to a UI and to the wallet, so you can actually have full end-to-end application talking to a chain, in particular, obviously, the Agoric testnet, once this is deployed up in the testnet. Okay, and there's both, again, fungible and non-fungible examples there where it's easy to do both. Okay, so we have a lot of other example DeFi Legos have been around and that we use. So atomic swap is sort of the obvious, the non-custodial trade where I'm going to make an atomic swap of concert tickets, and what I want when I make that atomic swap is I want to get 3 quatlus. You get the other end of that contract. You're my counterparty by getting an invitation to the other seat at the table of this contract, as it were. And you need to provide the quatlus, and if so, you will automatically get my concert ticket. They will be swapped for you. And there's a bunch of key elements of the contract framework in which we deploy all of these that make it safe and powerful to be able to safely interact with other parties. There's what we call safety properties, right? If you're familiar with memory safety or type safety, right? With memory safety, right? In C, sometimes you'd have a bug in the program, and now a pointer that you thought was to a payment now is a dangling pointer that goes off to some random place in memory, and your whole system corrupts and crashes on you. There's a large class of bugs in the history of computation, especially security bugs, that come from that were entirely eliminated once you had memory safe languages like Java, C#, and JavaScript. And it's not that they moved around. It's not that they went anywhere. They were just gone, right? You were just programming at a better level of abstraction such that there's a large class of bugs that simply went away. Well, what our smart contract framework adds is similar safety properties at the economic level. So what we call offer safety is, instead of just sending you a bunch of quatlus or sending you a bunch of atoms, I say, I'm going to make an offer. I will give you these atoms as long as you give me a concert ticket. And then the contract framework underneath all of these DeFi Legos, as they're plugging together, the contract framework underneath provides that assurance. So the atomic swap contract is trivial because it's trivial to run because the underlying infrastructure it's in provides that safety, so the clients say, yeah, I'll give you this money as long as you give me that other thing, and then the infrastructure will just handle it. So that shows up when components are using each other, or connected to each other, when users are making offers to applications and so forth, to really raise the level of safety that we need in order to be able to take these kinds of applications mainstream. Okay, so simple exchanges, simple order book, auctions, automated market. We have auto swap, which is a Uniswap equivalent, or rather a multi-pool auto swap. Voting, something that's kind of been on people's minds. I have a presentation later on Thursday about pluggable and extensible voting contracts where the same mechanism that you'll be able to vote for on-chain governance, or you'll be able to vote for parameters in the stablecoin machine on our economy, you can just reuse that, not by copying the code, which can introduce bugs like lendf.me did that, and they copied compound governance code and lost $25 million as a result of a bug that got introduced in there. No, you just actually instantiate the very same thing in order to reuse it, and inside of your smart contract where you're parameterizing it with your liquidity token, and now you've got a governance mechanism, right? And that's a place where by having this same pluggable extensibility, right, there's an awful lot of DeFi, which is actually governance, being able to take some well worked out governance mechanism and not change it and invalidate its security reviews is really powerful, right? And having each vote be an independent contract that gets launched just for that vote and goes away once the decision is made means that one vote, if there was a bug, can't corrupt another vote. You've got all these safety properties. I'll come back to covered call and OTC desk if we have time at the end, but I want to move on to what's missing here, right? And the answer is, of course, oracles, right? None of those had the connection that we need to the real world to be able to do the much broader set of transactions, the much broader set of use cases and examples that we all know we want and the mainstream requires, right? And so we have a bunch of components, a bunch of these DeFi Legos. And when I say DeFi Legos, by the way, I mean DeFi Legos, which are separate contracts that run independently in their own little compartments, such that that corruption of one can't corrupt another, and so forth, right? And so we have Oracle components that are exactly that kind of contract and DeFi Lego. So what's the integration look like? What's the integration with Chainlink look like? What does an Oracle look like, right? Well, start, of course, is you've got Chainlink nodes on the left that can go out to the internet to do all the things that need to be done to connect to the world there, right? You know, to talk to your bank, to talk to brokerage houses, to get the gold prices, all the examples that Keenan talked about in our previous talk. That gets deployed and connects to Agoric solo nodes. Agoric solo nodes are the same engine that runs on chain, but optimized for running in the cloud on behalf of a particular application or a user, where it then gets the additional ability to talk to, for example, a Chainlink node right next to it, or even integrate together into a single deployment, so that it does that on the one side, and on the other side, it then connects with our inter-blockchain communication protocol and various secure protocols to the chain to be able to send and receive object messages in JavaScript over the wire in a very simple fashion using the promises that Markham and I invented back in 1988. And it's all very straightforward and familiar to developers in JavaScript UI, developers in Node, and so forth. Okay? And so with that, we connect over to an Oracle contract. This is in the Agoric SDK repository. There's an Oracle contract that implements the very simple integration that we did, that does currently a no-fee integration to the no-fee oracles in Chainlink, and already has the mechanics to be able to do fee, but we didn't do the plumbing to make that available, because the question is, how do you want to manage that? How do you want to arrange abstractions and reusable components to, for example, pool funds among a bunch of clients to be able to pay for a fee or so forth? You know, the Chainlink community has a lot of experience and thought already on how to do that. We're looking forward to someone building something interesting there and winning the prize of best integration enhancement. Right? That's one of the main places. So that provides the general query interface into the Chainlink Any API, which is very powerful. That's the plumbing to be able to surface that, but surface that in a very JavaScript friendly, easy to use way. But there's an even simpler mechanism, which is the aggregator implementation. So there's an API we defined, and love your feedback, love your experience, etc. There's an API called the price authority. Now in our system, we have a time authority where you can say, this contract will expire at 3 o'clock according to that clock there, where that clock happens to be, tracking the Ethereum block height over IBC, or it happens to be going out through an Oracle and getting the real time from NIST or something like that. The nice thing is our system is very pluggable. That's another reusable component that you can get, so you can have contracts on our chain, settled according to time on another chain, or setting according to a local time or real time, or set or according to the holiday schedule published by the New York Times, or whatever it is you're going to agree to cooperate with someone around. That's a time authority. We have the same thing for price authority, where you can have a contract that will settle or that will react once the price crosses a certain threshold, or a react when time crosses a certain threshold and it gets a price, and that sort of thing. And I'll go into some of those. But the other thing is indeed you can write contracts that go directly to that use a query call to go directly to that more powerful interface in order to build the next level of aggregator. And indeed, this aggregator is just one of these contracts, one of these another contracts that is a client of the Oracle contract, to be able to roll it up in ways that that some of you have a lot of experience with. So we've mapped over or brought in key Chainlink abstractions that you can then use or build more of. But the nice thing is this price authority, man, it just looks like a JavaScript eventual iterator. It looks like simple concepts that are already very familiar to JavaScript programmers, and so it plugs in as a Lego as just something you can quickly pick up and use. So we've got both powers of quickly picking up and use already provisioned data, plumbed all the way through into an easy, consistent, standard JavaScript API that you can plug in and rapidly leverage the data that will be available on chain. So let's look at an example of that. Let's say you have a loan provider where you can come in and here's some collateral, I want some stablecoin or whatever it is. That has access to a particular Oracle, particular price authority, the aggregator that is sort of a central part of this Chainlink integration. But one of the key elements is we already have a loan contract. And the other thing that the loan provider needs is an AMM, where in our case, the loan, once it crosses a liquidation threshold according to the price feed that we get from out in the market, it will then liquidate on a local AMM. That's a useful architecture here, right? And so that's what we want this loan example. And indeed, that loan example, Kate is going to walk through in detail on Tuesday. And so Patrick will walk through how to do all of this wiring to hook up your oracles, and then Kate will show how it all integrates and how the loan contract functions. Okay, and so every time I come in and do a loan, instead of it being let's make this loan thing more complicated, it instantiates a brand new instance of the loan contract, right? There's this notion of not, here's an address of some random thing and it's a contract and I want to kind of pry the source code out of it so I can reuse. No. The notion of the source code of the contract deployed to our chain, that's an object that I can now get ratings on, I can get approvals for, I can get security reviews, I can get, attributes on chain, so that when someone instantiates a new one of those, I know that, by gosh, it's running the loan contract that I already verified. And it doesn't matter who the loan provider is. I can get a loan contract from anyone that obeys the contract that, that my insurance provider says, yep, that's the loan contract that we're insuring. Get one of those and you're good, right? And so we instantiate this loan contract with a reference to the particular aggregator, the particular price feed that the people that want the loan require, and a pointer to the AMM that we wanted to liquidate on. And so Kate will walk you through, here's how liquidation works. When the aggregate, what this loan is doing is it is signing up. So each loan contract is a separate contract, and it's signing up to liquidate on a price-based notification. So this is one of the another key differentiator of the Agoric platform versus Ethereum is it's an async active platform. You can have a smart contract that wakes up every week to rebalance your portfolio, right? You can have a smart contract that wakes up every 5 minutes in order to see whether it's time to go and sell something that you've been waiting to sell because you're waiting for the market to thicken. In this case, you can sign up for this price authority to get notified when the price crosses a threshold up or down, right? And so now I want a loan that when it crosses this threshold, I'm going to liquidate, right? And so that's a really awesome, powerful thing to do that with one line of code in JavaScript that millions of programmers could understand. Okay? So yes, apparently I'm running out of time here. I'm almost done here. So another component, another smart contract that we'll talk about is a call spread. Now, one of the economists that helped design the Agoric crypto economy and a bunch of these mechanisms will be presenting on Monday about how the call spread is able to cover a large range of financial interactions. And then Chris Hibbert, after that, will be walking you through the code to show how it works, right? And so a call spread is I was told, a linear payoff sandwich between two constant payoffs, right? The important thing is it's something that can be used as a component itself, simply parameterized to accomplish a vast number of other use cases. So the very same contract can be instantiated to do a put option, to call options, futures, binaries that you would use to do prediction markets. That's something that people maybe are really familiar with in the last couple of weeks, right? Collateralized loans, etc. That same contract. So not only can I plug components together, but I can take components that are rich components that people understand, parameterize them, and use them already. And so my big question for everyone out there is, can you take these components? These are the components, right? The question is, who's going to make a market, and how does a human get to it, and how do we get the right liquidity, and how do you trade them, and what are the right packagings of call spread in order to satisfy the needs that traders have? That's an exciting area of growth and innovation, and one can also take these and do some innovation on them directly, right? So what will you build? We're really looking forward to hearing about that, and we'll be around for questions or to talk about each of these things. All of the Legos that I pointed at here are in the source code tree in Agoric SDK. There's a presentation tomorrow, or a workshop tomorrow, by Michael Fig to help you get set up in the Agoric SDK if you need it. And then to walk through, as I said, how the initial contract wiring works. And finally, there'll be a bunch of workshops later on each of these different contracts to be able to be able to leverage them, build them, understand them, enhance them. So please join. I'm looking forward to you helping make DeFi even more exciting and a whole lot less dangerous by operating this nice, safe, composable space. Thank you very much, and I look forward to your questions. And now